In this video, we are going to learn about Fourier transform. If you have already learned that in the universities, don't worry. Today we are going to tell the basic things and why we are using this Fourier transform in our circuit and signals modules. So first of all, we need to identify that this Fourier transform is not introduced from an engineering side. It's actually having a mathematical background. In the mathematics, they have used this Fourier transform for their purposes to transform the domains. Let's say if you are having a function with respect to a specific domain, let's say it's going to be time, so it's actually in the time. If you want to shift this for the inverse of this domain, actually we already knew that if the time is going to be second, the inverse of this time is going to be second minus 1, which is going to be the frequency. So if you like to shift the domain of that function from time domain to frequency domain, which means if you like to change the domain from its original domain to inverse of this domain, you need to use some functions. That function, one of those functions, is known as Fourier transform. Actually, there are many other functions to do this transformation. So that's the main idea. But in signals and circuits controls module, you are going to learn the function using the Fourier transform. We are going to transform that function from the time domain to frequency domain. So that's the important thing. So here, this is the notation, but you don't need to understand what's over here and how it's changing its domain, because it's actually from mathematics side. But here you need to understand that if you use this function, you are going to change the domain from time to frequency. I hope now you have an clear understanding why we are using this Fourier transform. The first line denotes that xf, which means the Fourier transform function, which means we have shifted this xt, the time domain function, to frequency domain function. So we have taken the xt and we are doing some process, which is, you can see over here, this portion. If you do this, you are going to shift the domain to frequency. That is known as xf, Fourier transform of this function. Or else you can tell the frequency domain function of xt. And the same way, you can retransform, or you can get from the frequency domain back to the xt. How you can do is, you need to do another function which is known as inverse of the Fourier transform. So first of all, let's understand this equation first. As you can see over here, you are going to multiply this xt, the time domain function, with a particular value. It's going to be e to the power minus 2 pi j ft. Instead of 2 pi f, you can actually use omega, but there will be some problem when you are converting from xf to xt if you are using omega. That's why we have used 2 pi f. It's not that much problem. If you are using omega instead of 2 pi f, when you are finding the inverse Fourier transform, instead of this equation, you need to add 1 over 2 pi. You need to multiply this answer by 1 over 2 pi if you are using omega instead of 2 pi f. That's why we have used 2 pi f. So what we need to do is e to the power minus 2 pi j ft, and we need to multiply by the function which you need to change the domain. If you do so, and you need to integrate from minus infinity to plus infinity. If you do so, you are going to get the Fourier transform. Likewise, if you already knew this Fourier transform function, which simply means if you know some functions which is having frequency domain, if you like to change back to the xt, the time domain function, what you need to do is, you need to multiply by e to the power 2 pi j ft, which simply means, actually here we are not having this minus sign. That's the only difference. If you multiply and get an integration of those things, you are going to get the xt.